Today we're going to be looking at evaluating functions, and for today we're going to be looking at charts. This word evaluate means to figure out. Okay, usually you get a numeric answer when you evaluate, not always, but in this case you will, for the most part. And we talked about what a function is. For every input there's no more than one output. Numerically just means basically you're going to be given charts or points, not a graph or an equation. So we're going to figure out functions given charts. Example 1. Okay. The table of a function is given by this, okay? We can call it h, f, g, whatever. In this case, it's called h of x. And so we have some x values followed by some y values. Notice no x value has more than one y value, or h value, whatever, and therefore it's a function. So it says evaluate h of 19. Now notice we have parentheses, okay, and then the number inside. Okay, so that's how you read it. When you have h is the function, parentheses, basically when you read it you say of, and then 19 is inside. So h of 19. I'm going to teach you guys how to figure that out. Okay, so guess what? It's confused. When I first saw this, I was like, wow, this is blowing my mind. It looks like h equals 19, right? I mean, you have an h and then the 19 next to it, but it's in parentheses. And so basically what it means is you're plugging in 19. Now what are your inputs? Are your inputs, x or y, x or h of x? It's x, right? And so you're figuring out what h is by making x equal to 19. So the number that goes in the parentheses is your input or your x value. That's why you want to locate that number in the input column. Okay, locate the input number in the chart, which in this case, 19. So that number that's in parentheses, you're going to look in the input column, which is usually x, not the output column. Now it's confusing because it says h of 19. We're figuring out h by plugging in 19. So there's 19. All right, now we want to determine the corresponding output. We're trying to figure h out. Well, in the chart, it says x equals 19 goes to h of x equals 4. And that's it. And so when you write out what h of 19 is, it's just going to be equal to 4. Okay, on the chart, you look at 19, the y value is 4, and it's that simple. Very, very simple. Okay, next example, example 2. All right, the following is given by same chart. Okay, exactly the same chart. It says evaluate h of 1/2. Okay, so again, the number in the parentheses is what we're plugging in, our x value, and we're trying to figure out what h is. Okay, so h does not equal 1/2. The number in the parentheses is x. So there's our 1/2 right down there, and there we go. So that's in the input. What's the output going to be? It's that number 7, right? So since we plug in 1/2, we get 7 back. That's our y value, and therefore that's our answer. H of 1/2 equals 7. Pretty simple, right? So number in parentheses is what you're plugging in. The number you get back is your h of value or your function value, y value. Example number 3. Same chart, I believe. And so now we're going to figure out another question. It says evaluate h of 200. So if I plug in 200, what do I get back for h? Well, the problem is if I look for 200 in the x column or x row, depending on how it's oriented, there is no 200. Okay, so just a bunch of question marks. I have no idea what's going on. Well, if I can't find 200 here, I mean, how can I have a corresponding h value? I can't. Okay. In other words, there is none. There is no h value because there is no 200 in the x column or x row. So we say h of 200 is undefined. It's undefined because there is no x equals 200. All right, example 4. The table of the function f of x, so we're going back to f this time, not h, is given by the following. Here's your x values. Here's your f of x values. Evaluate f of the apple. So guess what? Your input doesn't always have to be a number. In this case, it's an apple, which is perfectly acceptable because when we go to look at the actual chart, there's my x value. So what's the corresponding y value? A, right? So there you go. My x value is the apple. My output is 8. It's simple. I mean, I plug in the apple and I get 8 back. So that's all you got to know. Pretty simple. Okay, had to fix that because it was a little glitchy. All right, there you go. You plug in the apple and you get 8 back. Let's keep going. Example number 5. Okay, here we have a function map, which means we have a column here and a column there and some arrows. We already learned about that. The arrow is where the number starts, and then the arrow tells you the output. So for example, negative 0.1 is your x value, the corresponding function value is 100, and so on and so forth. Evaluate f of negative 0.1. So all we have to do is look and see, okay, there it is, circled down there. F of negative 0.1, what does it go to? Well, you just follow it and it goes to 100, and that's the corresponding output. So therefore, f of negative 0.1 is equal to 100. Let's see if I have room to put it in one actual thing here. One line, there we go. F of negative 0.1 equals 100. It's simple. Example 6. All right, here we have a bunch of points which we can figure out, right? These are my x values. This is y, this is x, this is y, or g of x in this case. Same thing. So yeah, function notation, that's kind of the way it works. It kind of acts as y. But with function notation, it's written a little bit differently. We talked about that before. What goes in the parentheses is actually what you're plugging in. Okay, and then the number in front is your function value. In this case, it's g, but it kind of acts like y. So anyways, question for this one is evaluate g of negative 2.9. So I'm going to look again for parentheses. What's inside is x. So that's what I'm going to be plugging in. And in this case, I have to locate that in my set of numbers. Again, this means set of, this little braces, and then we have some points inside. So a set of points is a function, right? As long as each x value has no more than one y value. There is negative 2.9. What's the y value? It's pi, right? And so f of negative 2.9 must be equal to pi. It's very simple. All right, so I hope you learned something a little bit today about just plugging numbers in for input. You get an output for y. If you have any questions, let me know.